So in this video, I'm going to verify the answers that I got manually using Excel this time. So the average length of human gestation is 40 weeks, so that's going to be the mean, which we'll call mu. A baby is considered premature if the gestation is less than 37 weeks and overdue if more than 42 weeks. So we're going to assume that length of gestation, that's the thing we're measuring, so it's X, is normally distributed, and also that 5% of babies are overdue. So, part A. What we need to do is find the standard deviation of the length of gestation. So I've drawn the diagram that we constructed before for that process. X is the length of gestation, the mean is 40, and we're interested in overdue babies, which is this piece of information here, which was defined as more than 42 weeks. And we know 5% of those gestations have to sit in this section, so the area is 0.05. So in order to get the standard deviation out, we need to use our equation that converts between a z-score and the x values, the actual length of gestation. And if we rearrange this for standard deviation, we get that. So x, we already know that is 42. The mean we know, that's going to be 40. It's just the z value that corresponds to 42 that we need to figure out. And that's what we're going to verify with Excel. So if we convert to the z-scale, we know that the mean always goes to 0. And we just need to figure out this one here. And we're going to use this 0.05. Right, so jumping across to Excel, let's type in our mean. We said that was 40. And now I'm going to try and get our z-score out. So equals. And what we're going to pick this time is the norm inverse one. And what we want to put in here is the probability that is included in the section we're interested in. Now what we need to note though is Excel, when it calculates this, the probability it's going to assume is from the beginning, so if I jump back, from the beginning here all the way up until the cutoff point for which it's going to return you the Z value. So if we want 0.05 on this end, we need to figure out what area is then encompassed in the rest of it. And if we know the area of the total thing is equal to 1, that's going to leave the rest of this part here having an area of 0.95. So that's what we need to put in to get this particular cutoff. So it returns to us 1.64 approximately. So that's what I can put in for my Z value here. So now all we need to do is convert it. So 42 minus 40 divided by 1.64. And this returns about 1.22 approximately for the standard deviation. So let me just mark that in here. So that relates to X. Alright, so that's the first question answered using Excel. So the next one is to find the probability that a baby is born premature, defined as less than 37 weeks. So again, if I scroll down, I have drawn in the diagram. So we're looking at what's happening at less than 37. And we need to work out the probability, which corresponds to the area under the curve in this region. So to do this, one way is to convert it into the Z stuff. So let's go ahead and do it. So we know that the mean always goes to 0 when we do the conversion. And 37 we needed to figure out. So X, that's our point of interest. And the standard deviation, I'll mark it in here. But we got that from the previous question of 1.22. So this works out to about negative 2.47 approximately for the Z value. So now what we should be able to do is use Excel in order to figure out what this area actually is. Excel. So equals, and this time what I'm going to do is use the regular table. So what I need to give it is the Z value that I'm interested in, and of course we have that as being this negative 2.47. And then in terms of cumulative, we definitely want that option, okay? That means it's just going to add up all of the area from the beginning up until our cutoff point of negative 2.47. So it works out to 0.0068 we'll go with. Alright, so that corresponds to the probability. So it's about 0.68% chance of landing in this zone. Alright, so the very last one, I'll just scroll back up to read it. So find the lower and upper boundaries of the middle 60% of all berths. So I've drawn the diagram here. What we're looking for is these two cutoffs. I might just call them X1 and X2. And we know that this is in the middle and it's 0.6 for the 60%. So again, we need to go to the effort of using our Excel. Because we know the areas this time, it's going to be the inverse tables that we need to use. So this area we know is 0.6. If we work out this area in here, all right, we know the whole thing is going to be equal to 1. So this needs to be 0.2 then. And this other part on here needs to be 0.2 for this all to add up to give us 1. Alright, so if we're going to use our z-score stuff, let's focus on x1 to begin with. So we know that that inverse function works on calculating from all the way from the left the area up until your cutoff point, which is going to be x1. So we should be able to figure out on the z-scale what this corresponds to. So jumping over to Excel. So we're using the inverse function and we're picking the one with S in it for the function. So we just need to give it the probability up to our cutoff point. So we've decided that it's 0.2 up until x1. So let's pop that in. So that's our z-score at that point, so negative 0.84. Alright, let's do it now for x2. So again, remember the Excel function is calculating all of the area up until our cutoff. So we're going to need to include the 0.2 and the 0.6 this time to take us up to here. So that's a total of 0.8. Oops, sorry, 0.8. So that's the value we get out for our x2's corresponding z value. Alright, so now that we have our z values, we should be able to go back and figure out what that corresponds to in terms of x using our standard deviation and mean. Remember from that earlier question, standard deviation was about 1.22. So let's work with this one first. So if we want to work out the x value, we're going to need to rearrange the equation. So it turns into that, and now we're going to substitute in. So x1 is going to be negative 0.84 times our standard deviation, which was the 1.22, plus the mean of 40. And this one works out to be about 38.98 weeks. So that's the lower cutoff. If we then repeat it for x2, so using this equation, so it's going to be its z value, which is 0.84, times the 1.22 plus 40. This one works out to about 41.02 weeks. So that's the upper cutoff. So hopefully you can see that we can get exactly the same answers using both Excel and manual methods. It's just going to depend on what you prefer and what tools you actually have available at the time. So that's all there is for that question, and see you in another video.